Hello, today's question comes from Pure Mathematics Paper 2. The code is 9709 stroke 21, which was taken November 2019. This is Cambridge International AS level, that is advanced subsidiary level. The question of interest is question 6 in our series of looking at questions dealing with logarithms. So we look at question 6, which reads, showing all necessary working, solve the equation sec alpha cosec alpha is equal to 7. Within the range, alpha is within the range 0 degrees to 90 degrees. That's 5 marks. Then part B, showing all necessary working, solve the equation sin of beta plus 20 degrees plus sin of beta minus 20 degrees equals to 6 cos beta, where beta is within the range of 0 to 90 degrees. That is 4 marks. So this is the question of interest today, and straight away we move to the solution. Well, we look at a solution to that question of interest, and we have that this is Pure Mathematics 2, 2019, October-November sitting, question 6, as you have seen. So it is sec. Showing all necessary working, solve the equation sec of alpha cosec of alpha is equal to 7 for alpha within 0 and 90, within 0 and 90 degrees. That's 5 marks. So what we need to remember first is that sec of alpha should be 1 of cos of alpha. Sec of alpha is 1 of cos of alpha. Then cosec of alpha is, we can write it as cosec of alpha is 1 over sin alpha. So we have those two expressions. So we need to rewrite this. We need to rewrite this in these forms. So now we have that where there is sec alpha, I put this. Where there is cosec alpha, I put this. So it will be 1 over cosec alpha, this is a short form of cosec, this dot 1 over sine of alpha, 1 over sine of alpha should be equal to 7. That's what we have. Should be equal to 7. This is 1 cos, because it is cosec we want to represent. So it is sec we want to represent. So sec alpha is cos of alpha. So it's 1 over alpha. Then cosec of alpha is 1 over sine alpha. So that's what we have. Then we see that let's use the identity of there is this identity of sine 2 theta is equal to 2. Let me use alpha because it's alpha. We are dealing with alpha. So should say that sine 2 alpha should be equal to 2 sine alpha cos alpha. This should then imply that if I make this the subject, I'll be having sine alpha cos alpha is equal to sine of 2 alpha all over 2. So where I have this, I can write this. So this should then mean that the reciprocal of that then, because if that is 1 over this, which I've expressed as that, so the reciprocal, which will now be 2 over this, of 2 alpha should give us 7. Should give us 7 like that. And so it means, this implies that 7 sine of 2 alpha is equal to 2. And so sine of 2 alpha is 2 over 7. Is 2 over 7. Sine of 2 alpha is 2 over 7. Sine of 2 alpha is 2 over 7. So 2 alpha will be 2 alpha will then be sine inverse of 2 over 7, which if you check from your calculator, you divide 2 by 7 and check the sine inverse of that from your calculators, you'll find it to be around 0.28975. You need to check this using your calculator. And so if that's the case, then this is 2 alpha is this. It means that alpha will be half of this, which is 0.1446. So I would say that's around 0.145. 0.145. So that's alpha, 0.145 radians. That's radians, in radians, because so we say that's radians, 0.145 radians. This we can convert radians into degrees, because we know that 0.0175 radians is equal to 1 degree. So about 0.145, 0.145. That will be 0.145 divided by 0.0175. If you work that out using your calculator once again, you should be able to get around 8.3 degrees. 8.3 degrees. Now, if we want 8.3, if we get 8.3 degrees, but here we were asked that we should find angles which are between 0 and 90. It means that we can still find another angle. So the other angle, we find it by subtracting the 8.3 degrees from 90 degrees. If we do that, then we get the other angle. So one of the angles is 8.3 degrees, or 90 minus 8.3 degrees, which is 90 minus 8.3, that will be 81.7. 81.7 degrees. So there are two angles here. There is 8.3 degrees and there is 81.7 degrees. Both lie between 0 and 90 degrees. So that is as far as part A is concerned. So let's see what part B says. Part B that now is asking us to show, actually to solve sine of beta plus 20 degrees, beta degrees plus 20 degrees plus sine of beta degrees minus 20 degrees is equal to 6 of cos of beta. That's what we have. So we say this is now part B. This is part B. Let me say this was part A. This was part A. That's part B. Here now we let to simplify, yeah. So let A be, say, beta plus 20 degrees, and then let B be now B, not beta B, beta, not beta B. Let B, I'll write it at that. Then my beta, yeah, make create some difference, 20 degrees. Then we can use the identity sin of A plus sin of B is equal to 2 sin of A is equal to sin of A plus sin of B is equals to 2 sin of A plus B over 2 sin of A plus B over 2 cos of A minus B over 2, cos A minus B over 2. So sin of A plus sin of B is 2 sin of A plus B over 2 cos A minus B over 2. Well, now let's bring them using this identity. I just want to take this part that then should imply that 2 into sin of A, which is beta plus 20 degrees, plus B, which is beta minus 20 degrees, cos. So it's already have that over 2 cos A, which is beta plus 20 degrees minus beta minus 20 degrees over 2. This should give me, if simplified, it is 2 sin of, this will be 2 beta because this cancels this. If you open the brackets, 20 cancels 20, it's 20 minus 20 is 0, but then we have 2 beta over 2. So it's just sin of beta cos of beta cancels, then I have 40 over 2, so cos of 20. So sine of beta degrees, cos of 20 degrees. So, and this is equal to this, is equal to sin A plus sin B, is equal to sin A plus sin B, is equal to sin A plus sin B. And we had seen that sin A is this, sin B is this. So we have expressed all this in this form. So because I want to end up with the cos only, let me see what to do with this part. 2 sin 2 sin beta. 2 sin beta. So we have 2 sin beta. And so we need to work this out until we get there. So what that means is that this is this, which is this. So for this purpose, I write it cos of beta degrees. So that should then mean that I can divide each term by cos beta. If I divide each term by cos beta, then I will have here divided by cos of beta degrees. This side also cos of beta degrees. And so this then means that here I have 2 tan beta, then I have 2 tan beta because, okay, let me just proceed. So I have 2 tan beta because sin beta over cos beta, then cos 20. Is equal to 6. Is equal to 6. So 2 tan beta should be equal to 6 over cos 20. 2 tan beta is equal to 6 over cos 20. And so, okay, I've got 2 tan beta is equal to 6 over cos of 20 degrees, cos of 20 degrees, implying that tan of beta is 3 over cos 20 degrees, which is 3 over cos 20 degrees. 3 over cos 20 degrees should be about 3.192. Using a calculator, it's about 3.192. 3.192. So tan beta is equal to 3.192. That should then mean that beta is equal to the tan inverse of 3.192. That should then give us tan inverse of 3.192 is 72.9. Approximately 72.9 degrees. 72.9 degrees. And that's the answer. We stop at that because we were asked to get it between 0 and 90 degrees. Greater than 0, but less than 90 degrees. And so that's our answer. To our IGCSE students who are going to sit, I urge you to go through this question, try to master the identities. I wish you success in your upcoming exam.